Hello, in this video I'm going to look at finding a sample size. Now, we looked at basically finding confidence intervals, and we have that a point estimate for our population mean is given by the confidence interval x bar plus or minus our critical value of z sub alpha divided by 2, and then our standard error of sigma divided by root n. Now, this part of which that we look at is known as the margin of error. So the margin of error is given by basically, it's usually m, but we can say like it's the EBM. So that will be denoted for the product of our z alpha divided by 2, and that's multiplied by our standard error, sigma divided by root n. Now, what if we did not know the sample size, but we knew what the margin of error would be? Well, in that case, that would mean that if we, in fact, square both sides, then we can get rid of this radical sign. But note that if we use some algebra, basically what we could do is just say, well, multiply by root n on both sides, and then square it and divide by the margin of error. But either way, it gives us the formula that you have the same critical value of z alpha divided by 2, but that's multiplied by the standard deviation, and then all of this would be divided by what we call the margin of error. Now, of course, if it's m, then we would just put m, but in our case, we'll just say EBM, and what we'll do to get rid of that square root is square both sides. So this gives us essentially the formula for determining the sample size. So from here though, let's say for example that we knew a margin of error, we knew a standard deviation, but we would have to give essentially a confidence level. So one thing that we look at is, for example, if we talk about a 95% confidence, that basically this would be the same as taking basically 0.05 and dividing that by 2. Now, of course, in this case, the rate or the value that corresponds to a critical value with respect to a 95% confidence, well, that's actually 1.96. And even if we didn't have this, we could always say that, what is that? That's inverse norm. And essentially, you could probably just tell the calculator to take the remaining alpha divided by 2 and then just add it to 0.95, which in this case would give you 0.975 with a mean of 0 with a standard deviation of 1. And if we do that, then of course it gives us the 1.96, of which you can see is second vars, inverse norm, and for us we'll just do 0.975, and this will be that we're selecting the left side, of which we see that if we approximate, it's 1.96. So we have basically our 95% confidence critical value. And sometimes we actually just, don't even put the alpha over 2, but we just put, like a z asterisk to denote that that is the critical value. And in any case, let's say, for example, that we have that we're going to look at a IQ exam, of which an IQ exam, it's designed in a way of which the population mean is actually equal to 100 for the IQ score, but it's known that the standard deviation is computed to be 15. Now let's say that we wanted to conduct such that the margin of error it was within 3 units of the score, so we'll just say 3 for the margin of error. Now, if we go ahead and we find what is n equal to, well, what we'll have to do is we'll have to take 3, we'll have to plug in our critical value of 1.96, and we're going to multiply that by our standard deviation. But remember that what are we doing with this? We're actually squaring it entirely. So by doing that, we're just going to say that we're going to take 1.96, multiply that by 15, and then divide this by, well, in this case, we're saying that we're dividing it by the margin of error. And here, we're going to square that number to be 96.04. So we find that essentially the sample size is equal to 96.04. But in this case, we should make note that if we were to basically conduct such that we have a 95% confidence in estimating the true mean, well, this basically implies that we should sample not 96, but 97 individuals. Because in this case, we were talking about looking at an IQ score. So in this sense, we're saying that basically that we should sample 97 individuals, or in some cases, because this actually was conducted at a community college. So that means that we should sample 97 students in order to be able to construct this 95% confidence in any case. Which, if we did not know the mean to be given, which in this case it would be 100, but let's say that we didn't know that, and we just took a random sample of 97 students, then of course, yeah, we would have to look at the sample mean in that case and then just be able to construct that confidence interval that would, in theory, estimate what the population mean would be. So it would be interesting, like, if that could be done and that it could reconstruct it such that the population mean would be somewhere around 100 for the IQ score, given that, that is the actual average of a IQ score being 100 in either case.